Hi guys, in this exercise we're about to evaluate a definite integral. Definite meaning it has edges, boundaries and limits. What are the limits? Well, the limits for this particular example we're about to do in a moment has the limits from 4 to 1. They're the edges and boundaries of this particular definite integral. But first, let's have a quick look over here at the kind of a formula that represents what this definite integral concept is all about. So if we get the integral, or the antiderivative or primitive of a particular function x, we're going to end up with the primitives, capital F respectively, with the limits of b being the upper limit and a, the lower limit, substituted respectively into this formula. So let's kind of like do this example so we can gain some more clarity in how this works. So there's our function right over there, and what we're going to do is we're going to integrate it. So let's do that first. So we've got 2x take away 2. Well, we're going to raise the power by 1 over here. So it's going to end up becoming over here 2x squared. And then we divide by the square, don't we? Right, and subtract 2 over here. So let's do that. Take away 2x. We add the x there, don't we? And then what we do is we put a box around it like that. So it's 2x squared over 2 minus 2x. We've raised the power. We know how to do indefinite integrals, same kind of thing, but we put a box around it. So now on the box, we put the upper and lower limits on it. But first, let me write it out in a more practical format where it's already simplified. So let's just simplify that. So this will end up becoming, okay, square box around it. And now we're going to put the upper and lower limit, which is the 4 and the 1. So I'm going to color code it. So up the top we have 4. And many of your teachers probably won't color code it, but just to make it easy for you to follow. 4 and 1. Now all we have to do is substitute these into the primitive here that we've just created. And it's going to be the upper limit minus the lower limit, or b minus a. That'll be 4 minus 1. So let's substitute the 4 in here. So the first thing we do is we put the 4 in, and that's take away the 1. Sorry, actually take away the 4. So the 4 goes in the first part, like that. Then we subtract the lower limit, which is the 1. This is the subtraction up here. Let's put that in now. So we're going to put in here, because it says x squared, so that's going to be squared, and we put the 1 in there. Take away 2 times 1. So we subtract, this is the b part over there, and this is the a part. So let's simplify this, guys. This will be 16. Take away 8. So that goes here. Take away, let's see what we got in here. We got 1, take away 2. Can further simplify this. 16 take away 8. Well, that's easy. That's 8. Take away 1 minus 2 is negative 2. So that's 1 take away 2 is negative 1, sorry. So that'll be a negative 1. So that'll be negative 1. So it'll be negative 1. 2 negatives together make a positive. So I'm going to change it into a positive now. So that's a plus there. 8 plus 1 equals the answer, 9, and the answer is always a numerical value such as this. Now you might be wondering, what does this mean? What if we could see this represented as a diagram displayed? So I'm going to put together a diagram here so we can actually see what this 9 means and where it comes from. So let's have a look. Okay, displayed here is that diagram. Here it is, and we have this line along here, and that line is the graph, the line of 2x minus 1. Let me just write that in. Minus 2, sorry, 2x minus 2. That's the line right there. And you'll see that it cuts through negative 2 right there on the y-axis, and it goes through positive 1 there on the x-axis. So that's our straight line there that we just integrated. We want to find out now what those definite integrals mean. Well, let's have a look here. Our definite integral has limits on it. The limits are 4 and 1. Let's have a look here. Here's our 4 marked out right over here. So that's our 4, and here's our 1 right over here. So basically, from there to there, there, and there, that length across there, and the height along here, well, the height's going to be on the y-axis, which is 6, from 0 to 6, so the height's going to be 6. 6 high, 3 across. We could actually work out the area under that straight line. And that area is all in here, all the way down to the x-axis. That's what we just worked out. Let's have a closer look. So if 3 is across here and 6 is the height, we can work out the area using the triangle formula, half base times height, since it is a right angle triangle. So half times base times height will give us the area under this line here. Again, I'll just remind you of 2x minus 2, that's the line. Let's find the area. So that's going to be 1/2 times, well, across the base we have 3, and the height is 6 again. So that's going to be half of 18, which equals 9, the same as before. So this answer is correct. And this kind of displays what it all means. Now, if we're going to be working with areas later on, but for now, just recognize that the answer for this would need to be units squared. With definite integrals, it's just a numerical answer. So there you go, guys.